Hello students, I welcome you for the Computer Science first year online classes. Students, we already discussed in the last 9 session the first 2 chapter of Unit A, Fundamentals of Computers. Now today I am going to begin the next chapter, that is the data representation. So what we are going to learn in this chapter, so that I will keep it in front of you. So that is, objectives of this chapter is to understand a representation of data and information. In the computer, how you will represent the data, also information. In what way data will be stored. So to know that, we should know the number system. And at the same time, we should know conversion from one number system to another number system. The basic operations. This is what at the end of the chapter we will be there. So that's the reason I just wanted to keep it in front of you, the contents of this chapter. Yes, of course, I'm going to speak with you the introduction. Then I'll keep it in front of you non-positional number system, positional number system, then conversion from one number system to another number system, binary arithmetic, representation of signed integers, binary subtraction using ones and twos complement methods, and then computer codes. Yes, let me speak about the introduction. In computers, data and instructions are stored in a memory using binary code, or in another way we say machine code, that is represented by binary digits 0 and 1s is called bits. How these bits work in binary digit, that from binary I took B and digit I took IT. So bit means binary digit. The data may contain digits, alphabets, or a special character which are converted to bits that is understandable by the computer. See, as I told with the computer, we say that A, B, C, D, or see, my name is Arun. I wanted to store Arun is in the computer means ARUN I have to store. But whether computer will understand ARUN? Computer knows only bits, as I said. That's what we say machine code. Machine code will be there only in 0 and 1. Okay. So for A, there is a code is there. For R, there is a code is there. For U, there is a code is there. For N, there is a code is there. So altogether, this code put together, they sends to the computer. So this is called understandable code to the computer. So which is converted into bits. The code, it is not each in that digit is called bits. So which will be converted and it will be given to the computer. Now to know this properly, we should know the number system. The number system uses well-defined symbols called digits. So that bits, if you should know properly how this bits happens, we should be aware about the basic number system. Then only we will understand. Otherwise, we will not understand. As You know, the number system you all learned in your high school studies, the schools. You learned when you are in the Montessori school itself or kindergarten, the number means what? The number system are classified into two ways. One is non-positional number system, what we call, and the second one is a positional number system, we say. Non-positional and positional. So what do you mean by non-positional number system? What it is? Have you heard it? Have you used it? Or in your any calculation purpose you used it? Last 10 years you people have studied, no? Have you used it? Well said. So let me keep it in front of you. Non-positional number system. In olden days, people used to this type of number system for simple calculation like addition, subtraction. Yeah. The non-positional number system consists of different symbols that are used to represent numbers. They used to use the symbols to represent the numbers. Example, I'll just keep it in front of you. Roman number system is a best example for non-positional number system. See, they will use I for 1, V for 5, X for 10, L for 50, C for 100, D for 500, etc. So these are the symbols that they used to use. Now if you wanted to write 12, X 1 they used to write. That is X I. It means 12. If it is IX, if it is there means no, then they used to call 9. So this is the way this is there. Now here there is no position value will be there for the number. According to their understanding, the number they used to decide. Correct? So this type of number system is called non-positional number system. Then what is positional number system? Yeah. So this number system cannot be used effectively to perform arithmetic operations like multiplication, division, modulus. It is not possible. So that's the reason later onwards everything came with the positional number system. So I wanted to present in front of you positional number system. So what is positional number system? Positional number system means no, for position there is a value is there, such number systems are called positional number system. Okay, and let me keep it in front of you. Position number system are called, these are the different number systems are there. You heard about decimal number system, you heard about binary number system, octal number system, hexadecimal number system. How many of them know? So very well, decimal number system. How many of them used it? Everybody, right? In day to day, whatever numbers we are using, that is in decimal number system. Binary, maybe you learnt in schools, but let me teach you. So it's important in terms of computer. Octal, hexadecimal, how these number systems are there? I just tell you. So let me keep it in front of you so that time it will get more clear. The total number of digits present in any number system is called base or a radix. ನೀವು ಉಪಯೋಗ ಮಾಡುವ ಸಂಖ್ಯಾ ಪದ್ಧತಿಯಲ್ಲಿ ಎಷ್ಟು digits ಗಳಿವೆ, how many different digits are there in that number system, total number of digits, That is base or radix. Example, in decimal number system, how many digits are there? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 digits are there. So that time what becomes base of this number system? 10. Similar way, binary you are using only two, 0 and 1. So base of this number system is 2. So that means every number is represented by base x, which represented x digits. Decimal means 10 digits. Binary means 2 digits. Octal means 8 digits. Hexadecimal means 16 digits. Hexadecimal means 16 digits. Yes. Now example, how the number system will be written. In the number system, the numbers will be written in this way. In the number system, they will make use of subscript or the base is written after number as a subscript. So that time we will come to know which type of number is there, or it belongs to which type of number system. Now here you see in the slide 512 and subscript is there 10. That means this number is there in decimal number system. This is there in a decimal number system. So let me explain you the first number system, that is a decimal number system. It is the most widely used number system. Everybody is using, even in the school, to teach for the students numbers, they'll make use of this number system itself. The decimal number system consists of 10 digits and digits from 0 to 9. Yes, everybody knows, right? Yeah. So not again I'll tell you which and all the digits are there. It has 10 digits and hence its base or radix is 10. Right? So base becomes 10. These digits can be used to represent any numeric value. The combination of these digits itself become a number. Okay? The combination of these digits itself becomes a number. 100, it's a number. 1, 2, 3, 4, it's a number. 7, 8, 9, it's a number. The combination of digits. Examples, you see. 123. I am showing here this as a base. Base in the sense what type of number system is this? 456, 7890, 123.125. Got it? So I think you have understood what I am trying to tell you people. Yes. Similar way, let me show you one simple example how this number is represented. Consider a decimal number, that is 542.44, which can be represented in equivalent as. Now this is position is. So how this is position you are calculating? From decimal point as goes to the left side, the position will be calculated. The first is 0, then 1, then 2, 3, 4, like that you will calculate it. Or 10 to the power 0, 10 to the power 1, 10 to the power 2 you will calculate it. This is the way, that's a reason. 5 into 10 to the power 2, 4 into 10 to the power 1, 2 into 10 to the power 0, And from the decimal point, as you go right side, -1, -2, -3, -4 it goes. That becomes power of base of that number system. So that means 4 into 10 to the power -1, 4 into 10 to the power -2. So this is another way I can tell you paper. Here you see the 5 is there, this is 100, the weights is 10 to the power 2, the value is 100 and the digit is there. So that means this position value is there 500 because 5 into 100 means 500 it becomes. And this is become 10th position, okay, 10 to the power 1 is there. So 10th position, 4 into 10, 40, right? This is 1's position. So 10 to the power 0, 1, 2 into 1 is 2 itself. And this is next comes 1 by 10th position, 10 to the power -1. So that becomes 0.1. So this becomes 4 into 0.1, that is 0.4. Next is the 1 by 100th position, 10 to the power -2, that becomes 0.01. So that if you multiply, 0.04 it becomes. Altogether, if you add it together, 542.44 it comes. So this is about decimal number system. Similar way, going for binary number system. Binary number system also it represents in the computer. So to represent any digital information or data, we'll make use of binary number system or a binary form. So that is the reason this number system is very important for us to know. Okay, so all of you try to understand this number system. If you have any doubts, please WhatsApp me or phone by call. You clear the doubt. Don't keep it with you. So here, if you see, the binary number have a two state, 0 and 1. 0 is called the low state or low voltage, and 1 is called high voltage or upper state. Now, as here only 2 digits are there, so radix or a base of that number system becomes 2, and each digits are called here bits, and 0 and only 1 are using. And this is here positional values are expressed the power of 2, as in the decimal number system 10 to the power we used to use, here 2 to the power we will use. So just these are the example numbers. See here you see 1 1 0 0 0 1 1, base is 2, 1 1 1 1, base is 2, 1 1 1 0 0 1.101, base is 2. So 1 1 1 0 1 1 1 dot or a point 1 1 0 0 1. These are the simple examples for binary number system. Got it? Yeah. Just I'll show you the representation. Now let me check out one simple binary number. 11011.1011. This can be represented. This is the way. So what you have to do? You have to find the position value from the decimal point as you go to the left side. So this is become 0, 1, 2, 3, 4. And as I told you, here what you have to do? Make use of 2 to the power. So 1 into 2 to the power 4. Next digit 1 into 2 to the power 3 plus 0 into 2 to the power 2. 1 into 2 to the power 1. 1 into 2 to the power 0. Plus now as you are going to from the decimal point right, that -1, -2, -3 it goes. So 1 into 2 to the power -1 plus 0 into 2 to the power -2 plus 1 into 2 to the power -3. This is the way it will be number will be represented. This is called position. This is called position, right? Any number system will be represented. This is the way itself. They'll make use of the radix or a base number system. They'll multiply by based on the weightage. That becomes power of that. See, this is 4th is there, 2 to the power 4. In case if decimal number means 10 to the power 4 becomes. Binary, that's the reason 2 to the power 4. So this is the way. See here. The weights 2 to the power 4, that is 16. 2 to the power 3, that is 8. 2 to the power 2, that is 4. 2 to the power 1, 2, 2 to the power 0, 1, 2 to the power minus 1, 0.5, 2 to the power minus 2, 0.25, 2 to the power minus 3, 0.125. Now, if you, this is according to the digits is there, is 1, 1, 0, 1, 1, 1. If you multiply and take a sum, you will get decimal equivalent. So that's a very simple. So it connected with the decimal number system. They are linked each other. I just want to tell you here the first from the left side first bit is called most significant bit. MSB they'll say. Right? MSB means most significant bit. That is from the left side first bit. From the right side first bit it is called LSB, least significant bit. Least significant bit. This is you keep it in your mind because most of the time when you will make use of, whenever I use this number system, look at the MSB or look at the LSB also. Going for the next number system, that is octal number system. Octal means 8. So octal number system has digits starting from 0 to 7. There are 8 digits are there in this. So that is the reason the base or radix of this number system is 8. Got it? Now position values are expressed in power of 8. Now last we have seen 2. Then before that we have seen 10. Here we have seen 8. And any digit, this is always less than 8. Any digit here, number here, no, that combination of 0 to 7 should be there. Okay? So 6418, it is not a valid number because 8 comes there. 8 is not belongs to this. Yeah. So these are the example here are there. 3456, 121, 3456.151, 5623, 4512. These are the example, but this is not a right number. So again, this is to show you people. This is also represented this the way. Here you see position you have to verify. 234.56 is their octal number. Now you have to identify the position and you have to express in the power of 8. Now this is position is 4 position is 0, 3 position is 1. 2 position is 2. So 4 into 8 to the power 0, 0, 3 into 8 to the power 1, 0, 2 into 8 to the power 2, 0. All we are taking the sum terms. At the same time, from decimal point this side when it comes, minus 1, minus 2. So 5 into 8 to the power minus 1, 6 into 8 to the power minus 2. This is the way we are representing. So that means, look at here how it represents. Now here 8 to the power 2 is there, 8 to the power 1 is there, 8 to the power 0 is there, 8 to the power minus 1, 8 to the power minus 2 is there. What is the weightage? That is, so 8 to the power 2, 64, 8 to the power 1, 8, 8 to the power 0, 1, 8 to the power minus 1, 0.125, 8 to the power minus 2, 0.015625. This is the value will be there. If you multiply by respected digits and if you take a sum, you will get decimal equivalent. So this is the way octal number system will be represented. And the last number system is there, that is hexadecimal number system in this chapter, the type of number system. So how it is there? Now hexadecimal means the number comes in our mind 16. Now here the number system consists of 16 digits, that is 0 to 9, 10 digits becomes. Then they will make use of alphabets A to F, A, B, C, D, E, F. A, B, C, D, E, F. So this is altogether it becomes 16 digits. Now A to F represent that is 10 to 15. So A value is 10, B value is 11, C value is 12, D value is 13, E value is 14 and F value is 15. Yeah, these values will be given to that, and as I told with you here, it's represented in that way, and that's the reason the basic of this number system becomes 16. The basic base and radix of this number system is 16. So this is an example how it represents. See, 1AB, it is a hexadecimal number, the base is 16. 1 FADE, 16 is there. 934.1C1, it is again hexadecimal number. 5FD3, 4BC2, it is also hexadecimal number. So this is what giving a brief idea about hexadecimal number system. But at the same time, let me keep it in front of me how it will be represented. I'm just considering 5AF.D2, this is a hexadecimal number, and that can be written this way. So we have to identify the position, and this is also expressed in the 16 power. Previous one 8 power because it's an octal. Now here this hexadecimal we are expressing in 16 power. The position is F position is value is 0, so that is 16 power 0 into F. Similar way A into 16 to the power 1, 5 into 16 to the power 2. So we are taking sum of each term, and if you are going from decimal point to right side, D into 16 to the power minus 1, 2 into 16 to the power minus 2. So this is the way what we are doing. Just look at that carefully. Now if you see this, if you see according to the weights, so that table comes in this is the way. Now 16 to the power 2 means 256. Similar way 16 to the power 1 means 16. 16 to the power 0 means 1. 16 to the minus 1 means 0.0625. 16 to the power minus 2 means 0.00390625. Now this 2 is as it is there. D or a 13, equivalent value is 13. This is F or a 15, A or a 10 I wrote, and this is a 5. If we multiply by a respected digit to this number, and if you take a sum, you will get a decimal equivalent number. This is the way, my dear students, we will represent all 4 different types of number system. That is decimal number system, binary number system, octal number system, and hexadecimal number system. Students, let me conclude this session is here. So this is what about number system we learned today. So make sure that for the next session when you are coming, you should not get confused between decimal, binary, octal and hexadecimal. So you have to see how many different numbers are there, how big number you can do it, all those things you should know. And in the next session, I will teach you, and I'll make sure you that how to convert from one number system to another number system. The one number it is there in decimal. Now decimal, like example, if I say 10 is there. So what is value in binary? What value will be there in octal? What value will be there in hexadecimal? This is what we are going to learn. So till then, take care, stay safe. May God bless you. Thank you very much.